There's an app on your phone right now that may be watching everything you do on your screen. Not watching in the vague data collection sense that we've learned to accept as the price of free apps. Watching in the literal sense, capturing what's displayed, recording your keystrokes, reading your banking credentials as you type them, and transmitting that information to a server that doesn't belong to you. This isn't a theoretical attack or sophisticated nation-state operation. In 2025 alone, over 77 malicious apps with more than 19 million combined installs were removed from the Google Play Store after they were confirmed doing exactly this. And Google just changed a fundamental part of Android specifically because they couldn't stop it any other way. Let's start with a documented case, because this specific story illustrates something important about how this threat works and why it's more difficult to detect than most people assume. A screen recording application called iRecorder was submitted to the Google Play Store in September 2021 and passed Google's review process. By that point in the review, it was a legitimate screen recording tool with no malicious functionality whatsoever. People downloaded it. They used it to record how-to videos, gameplay footage, and tutorial content. It accumulated over 50,000 installs. Then, in August 2022, the developer released version 1.3.8. This update pushed a piece of software into the existing install base called ARAT, which is a customized implementation of an open-source remote access Trojan. The update was delivered silently, through the same mechanism as every other app update, with no visible indication that the nature of the application had fundamentally changed. After the update, iRecorder was recording ambient audio from the device's microphone every 15 minutes and uploading those recordings to a command and control server. It was also capable of stealing files from the device, including photos, videos, documents, and saved web pages. The 50,000 people who had installed a legitimate tool for recording video tutorials were now carrying surveillance software that was regularly capturing audio from their physical environment. ESET, the cybersecurity firm that discovered and documented ARAT, noted something specific about the timing and patience of this attack that made it particularly alarming for anyone thinking about how to detect this kind of threat. The malware wasn't present at installation. It arrived quietly through a routine update that looked identical to any other maintenance release. The characteristic that makes this category of threat so difficult to address through conventional advice, which typically focuses on scrutinizing apps before you install them, is that the scrutiny at installation time doesn't capture the fact that the app you installed is not the same app running on your phone 12 months later. What was legitimate on day 1 can become malicious on day 365 through a server-side update or a payload delivered after the app establishes trust on the device. Now let's explain the technical mechanism that makes most of this type of screen surveillance possible, because understanding it reveals both why it works so effectively and exactly where you should be looking to find and remove the apps that are abusing it. The mechanism is called Android's Accessibility Services API, and it was designed for a genuinely important and beneficial purpose, enabling applications built for users with disabilities to interact with the phone in ways that standard applications cannot. A screen reader for someone who is visually impaired needs to be able to read the text displayed in every application, including applications from other developers. A voice control tool for someone who cannot physically touch the screen needs to be able to tap buttons, fill forms, and navigate menus in other applications. A Braille display driver needs real-time access to what's on screen to translate it into physical output. These are legitimate, valuable uses of a powerful system API. The problem, documented extensively by researchers at Malwarebytes in March 2026, is that the same capabilities that make accessibility services useful for assistive technologies make them extraordinarily useful for malicious software. An application with accessibility services permission can read everything displayed on the screen, including content in other applications. It can capture keystrokes. It can observe every interaction. It can inject touches and simulate user actions in other applications. It can even see the content of fields that apps have attempted to mark as sensitive, like password input boxes in banking applications. Malwarebytes described the situation directly in their March 2026 analysis. Banking Trojans can intercept two-factor authentication codes, capture credentials, and perform transactions without user knowledge, and two tricks dominate. The first is fake overlays. The Accessibility API lets you put overlays on top of another app's screen. Banking and cryptocurrency Trojan developers can use this to capture your keystrokes. The second is permission abuse. Once the Trojan has your passwords, it can authorize its own transactions. The MITRE ATT-NCK framework, which documents adversary tactics and techniques for cybersecurity professionals, lists screen capture as a documented mobile attack technique, specifically noting that background applications can use Android's accessibility services to capture screen contents being displayed by a foreground application. This is not an obscure theoretical attack. It is documented, categorized, and actively tracked as a real attack vector that real malware in the real wild is currently using against real users. What makes the current situation particularly alarming is the scale and professionalization of the stalkerware market that has grown up around this capability. Research published in 2025 and 2026 documents a global stalkerware market valued at $145 million in 2025, projected to reach $265 million by 2035. Commercial stalkerware applications like MS Spy, Spylix, iZai, and HoverWatch all explicitly market invisibility as a feature. No root required, invisible mode, each charging between $20 and $40 per month for subscription access to surveillance capabilities built on accessibility services. Security researcher analysis from Chocopic's cybersecurity blog, published in 2026, was blunt about the distinction between these commercial products and criminal malware. Their feature sets, keylogging, screen capture, location tracking, call recording, social media monitoring, and stealth mode are indistinguishable from malware. The only difference is the billing model. Here's how you find out if your phone is currently running one of these applications, starting with the specific check that matters most. Navigate to your phone's settings and find accessibility. Within the accessibility menu, you'll see a section for installed services or accessibility apps, depending on your device manufacturer and Android version. Tap on it. What appears is a complete list of every application that has been granted accessibility services permission on your device. This list is critical because it reveals which applications have the capability to read your screen, capture your keystrokes, and interact with other applications, including your banking apps. Go through every single entry. The question to ask about each one is simple and binary. Is this application a genuine, assistive technology tool designed for users with disabilities that I deliberately installed for a specific disability-related purpose? If the answer is yes, the entry belongs there. If the answer to that question is anything other than a clear yes, the permission is a red flag that warrants serious investigation. What you might find in that list if your device has been compromised is an entry with a generic name designed to sound like a system process. Security researchers and the cybersecurity community have documented stalkerware and malicious apps hiding in this list under names like System Manager, Device Service, Update Handler, and similar designations that sound technical and administrative rather than adversarial. One of the specific characteristics of these malicious entries is that they appear active, with their toggle turned on, despite the device owner having no recollection of enabling them. If you find any entry in your accessibility services list that you don't recognize, that you have no specific memory of enabling, or that has a name that sounds like a system service but isn't a recognized assistive technology application, treat it as suspicious and do not dismiss it. The banking malware landscape of 2025 and 2026 has made this check specifically urgent. Researchers at Zimperium, Malwarebytes, and Zimperium have all documented active campaigns in the current period using accessibility services as the primary attack vector. The Double Trouble Banking Trojan, analyzed by Zimperium in April 2026, uses a session-based installation method, where the actual malicious payload is concealed within the app's resource files. The malware disguises itself as an extension or add-on using the Google Play icon to appear trustworthy. And once running, it prompts the victim to enable accessibility services. The Chameleon Banking Trojan was documented in late 2024 as having been updated to bypass biometric authentication on Android devices. Alberiox, which this channel has covered previously in the context of banking security, specifically uses accessibility services to perform on-device fraud, reading screens and executing transactions while showing a blank screen to the victim to hide what's happening. There's a second location on your phone where recording-capable apps can establish themselves that most users never check, and it's the Device Administrator section. Navigate to Settings, then Security, then Device Admin Apps or Device Administrators, depending on your Android version and manufacturer. Device administrator privileges give an application elevated access to device management functions, and malicious apps that combine this with accessibility services. Access create a combination that is particularly difficult to remove because the device administrator status protects the app from standard uninstallation. The new banking Trojan, analyzed by Malwarebytes in November 2025, was specifically documented as adding itself as a device administrator app, along with requesting accessibility services, creating a dual protection against removal. The combination makes the app resistant to standard deletion. Trying to uninstall it without first revoking its device administrator status typically produces an error or a refusal. The removal must happen in the reverse order of installation. Revoke device administrator status first, then revoke accessibility services permission, then uninstall through normal app management. Here's how to complete both removal steps for a suspicious app you've identified. In Device Admin Apps, find the suspicious application and tap it to open its details. There should be an option to deactivate or disable administrator access. Tap it and confirm. Once device administrator status has been revoked, return to settings, then accessibility, then installed services, and revoke the app's accessibility permission by toggling it off. After both elevated permissions have been stripped, return to settings, then apps, find the application in the full list, and uninstall it through the standard uninstall process. At this point, the application should uninstall successfully. Let's also address the Android 15 screen spying protection that was documented by GuardSquare in June 2026, because it represents a significant change in how Android attempts to protect users from this category of threat at the operating system level, and understanding it clarifies both what's improved and what vulnerabilities remain. Android 15 introduced a callback system that apps can implement to receive notification when another app starts watching their screen, allowing apps like banking applications to detect when screen recording is happening and respond by hiding or obscuring sensitive content. GuardSquare's analysis confirmed that this feature is effective and useful for protecting apps that implement it properly. However, several important limitations were identified. The protection requires the banking or financial app to specifically implement the callback, and not all apps have done so. Sensitive data can still leak through the screen in some configurations. And critically, on devices with ADB enabled, or when malware has obtained root privilege, the protection can be bypassed. The conclusion from GuardSquare's researchers was that the Android 15 protection significantly raises the bar but doesn't eliminate the threat entirely, making the user-level permission audits described earlier still necessary. Google went further in March 2026, with HelpNet Security reporting that Google is restricting how Android apps can use accessibility features after years of abuse by banking Trojans and mobile malware. The changes, introduced in Android 17.2, limit access to the accessibility API when advanced protection mode is enabled. Apps that do not serve a core accessibility function can no longer use these services, closing off a common attack vector. This is the most significant structural response Google has made to the accessibility services abuse problem. And it's important because it represents an architectural change rather than a policy change. Previous policy changes, updating the developer program policy to restrict accessibility services usage, removing individual malicious apps from the Play Store, required Google to identify and respond to individual violations after the fact. The Android 17.2 change restricts access at the API level for devices with advanced protection mode active, preventing applications from obtaining the access in the first place. But here's the limitation. Advanced protection mode must be deliberately enabled by the user, and it is not the default configuration. Every Android phone shipped today, including phones running Android 17, has accessibility services available to any app that can persuade the user to grant the permission, unless the user has specifically found and enabled advanced protection mode. And enabling advanced protection mode carries trade-offs. Apps that were using accessibility services for purposes that aren't core accessibility functions will stop working, which can include some legitimate applications like certain automation tools and screen readers for productivity purposes. Here's the complete action plan for addressing this threat on your current device. Start with the accessibility services audit in settings and review every app in that list against the specific question of whether it's a genuine disability-focused accessibility tool you deliberately installed. Any entry you can't immediately explain should be investigated by searching for the app's full name alongside the word malware to see whether it's been documented in security research. Move to device admin apps and apply the same scrutiny. Check which apps have been granted the display over other apps permission, which is a separate but related capability used for the overlay attacks that allow fake banking login screens to appear on top of real banking apps. Find this in settings, then apps, then special app access, then display over other apps. Review the full app list in settings, then apps, looking for any application with an unfamiliar name, a generic system-sounding name, or an app you have no memory of installing. For ongoing protection, enable advanced protection mode if your device runs Android 17 or later. Settings, then security and privacy, then more security and privacy, then advanced protection. This closes the accessibility services attack vector at the architectural level for your device. For devices running earlier Android versions, make the permission audit a quarterly habit rather than a one-time event. Because, as the iRecorder case demonstrated, an app that was clean when you installed it can become malicious after an update, meaning your most recent permission audit is only as current as the last time you ran it. The screen that your phone is displaying right now, including this video if you're watching it on your phone, is technically readable by every app on your device that holds accessibility services permission. For an app that holds that permission legitimately, like your screen reader or your Braille display driver, that's exactly what you want. For an app that holds that permission because a malicious update added a rat after you trusted the original legitimate install, it means your screen, your keystrokes, your banking credentials, and your private messages are being observed by someone who specifically designed the software to be invisible and who is specifically interested in everything you do on your phone. The audit takes 5 minutes. The permission revocation takes 30 seconds. The protection it provides is specific, documented, and necessary given the active threat landscape that security researchers are tracking through 2026.